Hello everyone. In this video, we are going to talk about the product process and schedule designing. In the previous video, we learned about where to place a facility. Now it's time to look inside the facility. We will discuss how process design works, how products are manufactured, and how layout planning depends on these choices. As industrial engineers, we must understand that production methods directly change layout decisions. The way we process a product decides how much space we need, how materials flow in the factory, and how we arrange workstations. Today we will learn about the main steps of this procedure, including make or buy decisions, bill of materials, BOM, and route sheets. Let's start with an overview of process design. First, let's look at what a process designer actually does. The process designer determines exactly how products will be manufactured from start point to finish point. This means selecting the appropriate equipment, estimating the operation times for each task, and also deciding for which machine performs each processing step. Because of this, process design is a fundamental to efficient facility planning. To do this successfully, we follow a specific process design procedure. Actually, it's always begins with a very important question. This is the main idea, one of the most important question. Make or buy decision. We have to determine which components we want to manufacture inside our facility versus which parts we should purchase from external suppliers. Uh, Once we know what we are making, the next step is part list generation. Part list generation shows us the all requirement components along with their exact quantities. After that, uh, in the last part, we are going to organize bill of materials. Boom. This is a tree of um, raw materials. Uh, then process selections comes to find the absolute best manufacturing methods for each part. In the final seconds, included with every previous parts, we are producing a root sheet document to visualize all of the tools we use, assembly charts, prediction diagrams, operation process charts, blah blah blah. Uh, in first, we are going to check about process design procedure. Then we are going to look at make or buy decision. We will talk about this deeply. And last, we are going to check about the process identification, bill of materials, and assembly tree format. Let's go with make or buy decision. Let's do a deep dive into make or buy decision because it changes everything in our facility layout. It's the most important thing for us. Management must look at this problem from two main sides: managerial considerations versus inflation factors. First, under managerial things, we have four Ks: finance, marketing, engineering, human resource. And second, what we are the influencing factors that help us choose. Of course, cost analysis is a critical point. We compare the cost with external purchasing prices, and we must include hidden costs like shipping, inventory cost, fixed cost. We also assess capital availability for machinery and supplier options to evaluate if external market alternatives are reliable and meet our quantity standards. If we want a middle ground, we can consider subcontracting for non-core manufacturing activities. Let's go to part list. BOM. BOM means bill of material and assembly trees. Uh, firstly, we are going to talk about part list generations because it starts with part list generation. This catalogs every component with a unique part number, descriptive name, and quantity needed per finished product. It also references technical drawing for manufacturing specifications. This list directly can be transformed to BOM. BOM means bill of materials. The BOM adds a hierarchical structure by organizing components into assembly levels. Uh, this allows us to track parent-child relationships systematically. Uh, BOM has three levels: level 0, level 1, and level 2. Uh, Level 0 is the top. It's presenting the final product. Level 1 is half finished, semi-finished raw materials. It's the middle side. And level 2 is our lowest uh, point in our BOM. It shows the raw materials. To perfectly visualize this hierarchical structure, we draw an assembly tree, as you can see from the slide. Uh, this diagram helps us, the production planners, understand the dependencies between the different components, raw materials, semi-finished goods. Uh, it allows us to identify critical assembly sequences and ensure that all necessary parts are available before any assembly operation begins on the floor. Uh, Before every process, we have to check this assembly tree actually. Now we are going to talk about process selection and root sheet documentation. This is the last part of this video. Process selection procedure. Once the product structure is clear, we perform process selection using a systematic six-step approach. These six steps are: first, we define element operations by breaking the production down into the smallest possible work units. The second one is we identify the alternative process and equipment. The third one is we analyze these alternatives based on a technical feasibility and capacity. The fourth one is we standard our process to keep these things consistent. The fifth one is we evaluate alternatives using cost, quality, efficiency, all of these criteria. And finally, we select the optimal process for our goal. Uh, After all of these sequences, our final document will be root sheet. Root sheet is a comprehensive guide for production planning. It's the most detailed document. Includes operation numbers, sequences, task descriptions, specific machines can be used, setup time, run times, costs, quality checks. All of this include root sheet includes all of this. You can see the key takeaways in this slide. Uh, Thank you for watching this video. Next videos we are going to talk about the next topics. In this video we talk about bill of materials, assembly trees, root sheets, part list, and the importance of these trees on our production system. Thank you for watching us.